Welcome back to my channel, and here I have this question to solve. I found this question somewhere and I want to provide solution to it. If you are watching my video for the first time, thank you. Please subscribe to this channel, put on the notification bell so that whenever I upload a new video, you may be notified, and help me share my videos with your friends who are technical drawing students. And it's very important that you practice this subject. This is a practical subject. You can't say you are a technical drawing student and you are folding your hands doing nothing. You can't get it. So that's a matter of fact. So all you need to do, practice, and when you practice, you become a master at it. Okay. Now this question says that an ellipse has a major axis 120 and minor axis 80. Question A, Roman figure 1 says that we are to determine by construction the positions of the two foci and state the distance between them. That's question 1, A, Roman figure 1. And Roman figure 2 says that use the foci method to construct the ellipse in full size. That's question A, Roman figure 2. Question B, Roman figure 1 says that construct a tangent to the ellipse at a point 30 millimeters above the major axis and to the left of the minor axis. And question B, Roman figure 2 says that determine the distance of the tangent point from the two foci. Those are the questions that we have to answer here. And what we need to do first, as I'm going to show here, is to draw a horizontal line. So we have a horizontal line like this, and then we are going to draw a vertical line. So we draw a vertical line, so like this. So this is a vertical line. Okay, so now we take a measurement from this point. So let me call this point so this point that we have here, let me call it point O here. So this point, so let's call it point O. So the next thing we are going to do, from this point O here, I'm going to take a measurement of 60 millimeters to the right, to the left side. So, and then 60 millimeters to the right side. Okay, so distance from here, so I will call this point point A, and I will call this point, I will call it point B. So distance AB is the major axis. Now, so for the minor axis, as we are told in the question that the minor axis is 80 millimeters. So from this point O here, I will take 40 millimeters down here, and I will take 40 millimeters up. Okay, so this point is point D. So while this point is point C. Okay, now question A says that we should, A, Roman figure 1 says that we should determine the point of, or the foci, the two foci. We have to determine their position on the major axis. How do we do that? What you need to do is to take half of the major axis, which is OA or OB, which is 60 millimeters. So take that distance like this with your compass. Okay, take that distance with your compass and put the pinpoint at point C here. Then you make an arc on this side, and you also make an arc on this side. Okay, so looking at what we have here, so these are the points of the foci. So this is the point of focal point 1, so I will call it F1, and this is focal point 2. Okay, so let's see the question for us to know what we are to do before we continue solving this problem. Okay, as we have here that we are to determine by construction the position of the two foci and state the distance between them. So we need to state the distance between them. All I need to do now is to take the measurement between F1 and F2. So looking at what I have here, so this is about 79 millimeters, but this is what I'm going to say. So I just say that I have F1, F2. So F1, F2 is equal to, this is how you have to state it, is equal to 80. So 80 plus or minus 1 millimeter. So I'll just leave it like that. So that's the distance between the two foci, as we are instructed to measure a distance or to stay a distance between the two foci. So having done this, the next thing that we are going to do, as we are instructed in the question, let's see it. So Roman figure 1 question, Roman figure 2 question A says that use the Fossey method to construct the ellipse in full size. So to construct the ellipse in full size, so let's go and construct the ellipse. What we need to do now is to divide distance OF1 and OF2 into a number of equal parts. Okay, so I will also draw a line like this in this direction. Okay, so now, I'm going to divide this distance into a number of equal parts. Just make like 4. 1, 2, 3, and 4. Okay, so here also I will also make 4. So this is, so I took 30 millimeters. So 1, so this is 1, 2, and this is 3, and this is 4. Okay, so I will join the last point with point O here. Okay, so then here also I will also join the last point with point O as we have here like this. Okay, so the next thing I'm going to do is to draw parallel line to this line here. Okay, so I'll do that while I pause the video. Alright, so having divided distance OF1 and OF2 into a number of equal parts, that is 4. I'm going to number this as 1. So this is 2. So this is 3. So I will leave this one, I don't really need it. So this is 1, this is 2, and this is 3. So those 3 points are what I'm going to make use of. I will call it 1 prime, 2 prime, and 3 prime. So now I will take my compass. Alright, so then I put the midpoint of my compass at A, extend to 1 prime here on the right side here, 1 prime here. So I take this distance and lift it up. I put it at point F1 here, and I will draw an arc up and down here. Okay, so also I'll put the same radius at F2 as center. So I draw an arc up and draw an arc down here. So next is from A to 2 prime on the right side here. So I raise it up, put it at F1. So I make an arc here, and I make an arc here. Alright, then I'll put it at F2. So make an arc here, and make an arc down here. So the last one is 3 prime. So I will extend to 3 prime on the right side. So I put it at F1, and I'll draw an arc here on this side, draw an arc down here. Then I'll put it at F2, then draw an arc here, then I'll draw an arc down here. Okay, so those are the points that those are the first part to what you need to do first. The next is putting the midpoint of my compass at A, extend to 1 on the left side. So taking this distance, and then I'll put the midpoint at F1 here. So make an arc here, make an arc here to cut the first arc that we drew. So okay, then I'll put at point F2 here. So also make an arc to touch the first arc that we drew. So okay, the next is from A to 2 on this left side. Okay, so I put at F1 here, I make an arc here. So make an arc on the second arc. So do the same. So from here, so make an arc here, and I make an arc here. Alright, so the next is, so from A to 3. From A to 3. Okay. Then I put it at F1 here. So I make an arc here. So make an arc here. Okay. So I'll put it at F2 here. So I make an arc here. And also I'll make an arc here. Alright, so all these points, we are going to join them together with the use of French curve. So this point, so which I believe you know how to use. So I'm going to use my French curve to join this point together so that you can see how the ellipse will look while I pause the video. Alright, so this is the ellipse, so which I believe you can produce the curve with the use of your French curve. So so the next thing that we are going to do, we have answered question 1, question A, Roman figure Roman figure 2, as we are asked to use the foci method to construct the ellipse full size, as we are told there. So I want to bring the question up again for us to know the next thing that we have to do. I think that that has to do with question B, Roman figure 1 says that construct a tangent to the ellipse at a point 30 millimeters above the major axis and to the left of the minor axis. So this is the major axis and this is the minor axis. So above the major axis, we are drawing it up here, and on the left side of the minor axis, we are drawing it around here. So what we need to do is to locate point 30 millimeters on the curve. So we need to take a measurement of 30 millimeters from here. So this is 30 millimeters. Okay, then I need to get the point on the curve itself. So this is it. So I'll just draw a line like this. So this is the point. So the point is here. So we just bring it out like this. Okay, so this is where we have the point. So I will call it point P. Okay, so this is point P. So the point on the curve. Okay. All right, so now that we have located the point here, so the next thing that we are going to do is to join this point together with F1. So we draw a line like this. So we join together with F1, and we also join it together with F2. So join together with F2. Don't forget that we are asked to construct a tangent to this point on the ellipse. So what we need to do now is to bisect this angle here. This angle, so we have to bisect it. So to do that, we need to draw an arc like this. Okay, so we draw an arc like this. So we need to bisect. We put the pinpoint of compass at this point here. So we draw an arc here like this, and then we put at this point here, we draw an arc like this. Okay, so the arc intersects at this point here. So we're now going to draw a line from this point through the point on the curve. So we draw a line like this. So I'm going to make this line and make it thick from here to here. Okay, so this point I will call it, so this is point Q on the line. So I need to write that P. All right, so this line is a normal. So so this is point P. I'm writing it. Okay, so this line that we have drawn from here, this line PQ, is a normal. So we need to draw the tangent. So I need to make use of my my protractor. So I'll just set my protractor at this point on the curve and leave. So make sure this 90-degree line is on the line that we drew out here. So I'll just set like this, and then so make sure I can see the point. So I can see the point like this. Then I will draw a line like this. Okay, so this line is line RS. Line RS, and this line RS is the tangent to the point on the curve on the ellipse. So the next thing that we are going to do is to I think we have another question that says that we have to determine the distance of the tangent point from the two foci. Distance of tangent point from the two foci. So this is it. So I need to take a measurement of distance PF1. So distance PF1 is 31 millimeters. So I'll just write here. So PF1 so is equal to 31 so millimeters. So 31 millimeters, and also PF2. So PF2. So if I take this distance from here to here, so this is 90 or 89. Sorry, it is 89 millimeters. So PF2. So PF2 so is equal to 89 millimeters. So if we add PF1, so plus PF2, so it will give us AB. It to give us AB, which is the major axis. That is 31 plus 89. So that will give us what? That will give us 120. So, and the length of the major axis AB is 120 millimeters. So just bear that in mind. So all that we have done here is very simple. All you need to do is to practice. When you practice, become a master at it. This is a practical subject. So any student that is interested in technical drawing that cannot practice, that student is not yet ready to learn this subject. This subject is simple, just a matter of practicing, and you will become a master at it. Thank you, and don't forget to practice. God bless you.